Our next section here is to involve significant figures as we continue in chapter A. Significant figures. Chapter A, you can think of like the letters of the alphabet. If you go from A to Z, you have 26, and if you do 2 a week, you're looking at 13 weeks. And if you allow for exams, that's pretty much, this and the finals week, that's pretty much correlates to your 15-week semester in the university setting. So that's kind of why I picked the A through Z. This is when you're doing the Tuesday, Thursday mode kind of class where you're doing a 75-minute class each time. So what about significant figures? Well, we can approach this like some authors do and give you the rules, and that's fine. Nothing wrong with that. If you Google, you'll find kind of cool rules, but I like to show you where the rules come from. I am a theoretical physicist, and theoretical physicists tend to like to derive everything themselves. So I would like to derive the idea, what a significant figure means. So to do that, we'll look at a case here where we're measuring the diameter. So this is a silver dollar, a Susan B. Anthony coin made from 1979 to 1981, and then again later 1999, and we're measuring the diameter. So here you can see we have inches and we have centimeters, and it looks here, if you look at 2 centimeters and then 2.5, 2.5 is there. This is 2.6 centimeters, and this one's 2.7, and it looks like it's between the two. You might say 2.65. And some authors, like when they write papers, they'll do stuff like this, plus or minus 0.01 centimeters. So that's saying it's 2.65 centimeters, but I'm not sure. Like it could be 2.64, and it could be 2.66. So that's one way of expressing uncertainty, like that. Here, by the way, these little ones in here from 3 to 4, see those little notches? They're your millimeters. So 10 millimeters equals 1 centimeter. So we have here 26.5 millimeters. So milli stands for 1,000th of a meter. So you would need 1,000 of these little ones to have a meter. A meter's about a yard. And centimeter is like 100th. So this would be 100th of a meter. So you would need 100 of those to have the meter. We kind of did a good measurement here because that's what it actually is. It's made with that like specification, 26.5 millimeters. But this brings us the concept of the significant figures. We say there's 3 significant figures here, the 2, the 6, and the 5. And you might say that here, if we were to round off in a very generous way, right? A very big round off, we would round that off to 30. And see, when we do that, that 0 is not significant. It's not significant because this could be 29, rounds off to 30, 31 rounds off to 30, even 33 would round off to 30, or 34. So lots of numbers, see, can round off to that 30. So it's the 0 that we have to worry about. And I'm going to say that's the big round off. So when we're doing the big round off, like here, if you were to just nudge that to a 27, you doing a round off, like if you had a 26.9 and you were to round it off to a 27, that's a very small round off, and since no 0 appears, I'm not considering that as a big round off. This would have 2 significant figures, this would have 3 significant figures, and the problem is when you go to 30, because it's a big round off, Now, you can't consider that 0 significant. See, that 7 can be considered significant because, yes, if you nudge that up to the 7, that's what it is. It's definitely, you know, if it's 26.9, it would definitely be a 27. But if you push it to 30, it's not definitely a 30, because you could push, you know, a 31 would be pushed to 30, a 28 would be pushed to 30, 29.3 would be pushed to 30. So the 0 is not significant. So that's our first rule, that a 0 is not significant when it's at the far right. So let's look at these cases where we have, say, 3, and we have 30, and we have 300, and we have 3,000. These numbers have one significant figure, the 3. The others are not significant because you could have that big round off. Now, if you have something like 303, well, that 0 in the middle means no tens. This is no tens, and that is significant. Yes, that's significant. So it's only when you do this big round off that you lose the significance. So here we can start a little list of rules. 1, okay, each non-zero number, in other words, 1, 2, 3, 4, 5, 6, 7, 8, and 9. These are always, each of those, each gives one significant figure. All right. 2, any 0 that's between two non-zero numbers, for example, 303, any 0 is significant. So that is significant. Then, if we look at any zeros to the right of a whole number, they are not significant. So we basically know these rules from the common sense, that here when you have the zeros at the far right, but you know, we can make a list of the rules, but we are in a sense deriving these rules from a common sense. What about zeros on the left side? If you had, say, 4 cents, you can write 4 cents as 0.04, or you can write it as 0.04, like that. That is still 4 cents. You know, put like a dollar sign there, for example, like that. And these zeros don't add any more precision to the 4, so these are not significant. So we can have another rule that leading zeros to the left are not significant. Now, suppose you have 300 and you mean 300, like that 0 is significant. So there's an easy way to fix that. What you do is you put a decimal point right there, and that means, bam, that means we nailed it. That rounds off to 300. In other words, like you would round off to 301 or 299, the 300 should be treated just like these. So that would mean, say, a decimal point after a 0 indicates that zeros immediately to the left, are significant. So if I do 300 with the point, those two zeros are significant, and I have three significant figures. If I have 30 and put the point there, I have made this single zero a significant figure. That's very nice. Suppose you had 1.5, but you wanted to say, no, it's like $1.50. It's like I really have a zero there. It's like it's really what I have. It's like $1.50. Then if you put a zero to the right on the right of the decimal side, then that zero is significant. And that kind of makes sense that would be the case. So sixth rule, a zero placed after a number on the decimal side is significant. Now see, you don't really need to memorize all these rules because it's kind of like common sense how we're arriving at these rules by just thinking of that big round off, how to treat the big round off and when it's not a big round off. So these all are following from our analysis. We are deriving all these rules. So here, when we do calculations, there is a way, a rule that I learned in chemistry, and I'll give you an example. Like suppose we have a vehicle that's going with the speed, a velocity. Velocity and speed are used interchangeably in colloquial language, but I'll talk in the next section how technically one is a little different than the other. But for now, let's not worry about that. So you have here 10.1 meters per second. Now, whenever you say per, you can have a division there, like per second. Like if you went, for example, 100 miles in 2 hours, then if I divide by the 2, I get 50 miles per hour, and that's how you would write that. So you have the 10.1 meters per second, and say we have the time is 1.2 seconds. Okay, so now if you wanted to look at this and see how far you go, the distance you would go, if you're going 10.1 meters per second, but you're gonna go for 1.2 seconds, and notice here how those seconds cancel, and you're gonna be left with meters. You have 1.2 times 10.1. So this, without a calculator, let's see, I could do 10 times this to get myself 12. And then if I take 1/10 of 1.2, I get 0.12. So when I add these together, I'll have 12.12 seconds. So now we look at this. 3 significant figures here, 2 significant figures there, and here there's 4. So the rule is reduce this to the least accuracy, which is the 2 significant figures. So we should report 12. I learned that rule in chemistry. So when you have significant figures that vary in different parameters in the problem, then you round off your answer to the amount of significant figures that's the least accurate. And that would be this case here, the 2 significant figures. I found that when I taught engineering though, in engineering books, they often would give 12.1 in a case like this. They would just throw in one more. So if you want to be strict, like the chemist, this is strict. And I remember losing points in chemistry class if I didn't do this. Then you would be strict, you would do that. However, here, we're being just a little bit slack. one could argue, see, that's not significant. Technically, the chemist would be right. It's not significant. You shouldn't be doing that. You're not sure what that is. You shouldn't do that. But the engineers are a little flexible, and they throw in one extra one. They don't worry about it. So in physics, you can do either of those two. It's fine. What you don't want to do is if you had on a calculator something like this, let's make that a 3, all right, and then a 1 and a 2, and this went on for like a lot of digits. You wouldn't want to report that. That would definitely be bad. Okay, one final comment is we'll be doing a problem later where we're doing a stereo system where we have two of the same thing, so we just double the answer, like when you figure something out. So when you have something like a number that's like exactly 2, like you have 2 speakers, then you have an infinite amount of significant figures because it's exactly 2. So then you have an infinite amount of sig figs. And that's when you have something that's exactly 2 or exactly 3. So we could add a 7th rule. A 7th rule is that an exact number such as 2.00000, in other words, 2 equals 2.00 ... has an that has an infinite, an exact number has an infinite amount of significant figures. So therefore, if you're doing a chemistry problem and like you had just double something, you wouldn't consider that 2 as one significant figure and then reduce everything to 1. No. You would consider that as an infinite amount of significant figures and just leave the other answer the way it is, just double it. So there's 7 rules there, significant figures, and you really don't need to memorize those rules because if you just use the common sense and the idea of the big round off with the 0 at the end or the zeros, you can pretty much figure out what to do in any given situation.